All right, so here we are given several different polynomials and we're asked which style of factoring fits each polynomial. So for letter A, notice that both terms have a common factor of 3. In other words, 3 divides each term. So we're going to use greatest common factor, which is like undistributing. So we'll factor out the 3 and we'll still have what's remaining in the parentheses there. Letter B is an example of unfoiling, where there is no number in front of the x squared term. In other words, the leading coefficient a is 1. So we start with our parentheses. We put x and x for the firsts, and then the lasts are going to be the numbers that multiply to 20 and add to 9. Letter C is another example of unfoiling where the leading coefficient a is not 1. In other words, we have a number in front of the x squared. So a way of factoring this is starting with your parentheses, have 3x and x for your firsts, and then you'll use guess and check on the lasts with numbers that multiply to 8. Letter D is an example of difference of squares. You have a square here and a square here, and you're subtracting them or taking their difference. So for factoring them, just do the square roots, put them in parentheses. One gets a plus, the other one gets a minus. The last one, letter E, is an example of a perfect square trinomial, and the way you check for these is you square root the first and the last, multiply those together, and double. So for this example here, square root of 16 is 4, square root of 25 is 5. Multiply those together and you get 20, and double. There's the 40 there. Now, I did go pretty fast through these explanations, and I did not use very mathematically correct wording. So check out these other videos if you need more in-depth and mathematically correct help with factoring these types of polynomials.